Map projections can have a big impact on your map display and also your map analysis. In this example here, we're seeing two world maps in different map projections. This is the Mercator projection, which is a conformal projection. All of the shapes and the compass bearings are correct. However, the size of the different things on this map are completely inaccurate. So if we were making a map where we were trying to show a straight line navigation route between two areas, this would be a great choice. But if we were trying to show a map that showed population density, for example, this would be a terrible choice because the areas here are so much bigger. This would be a much better choice, although it looks more distorted to most people. This would be a better choice for showing population density. There's also some key questions with map projections, like should north always be to the north, or should it be designed for easy navigation? If it's a local map trying to show direction from one place to another, you might not want to put north at the top of your map. However, map projections can also have an important impact on analysis because, for example, if we make an equidistant map, all the distances on the map are going to be the same. But if we use geographic coordinate systems, those distances are not going to be reflective of the distance on the ground. So in this example here, we have three different hotels, and we're trying to analyze which, from all of these points here, which hotel is the closest. In this example here, which we made with the geographic coordinate system, it appears that these three hotels here are closest to, or these 3 points here are closest to Hotel C, whereas in fact, if we convert this to the Universal Transverse Mercator map projection, which does a better job at representing the distances, we can see that these three locations here are actually more proximal to Hotel B, which is really the distance that we would measure on the ground. So that's the better answer in this case. And this kind of leads to the question, well, if we have geographic coordinates and we have a map that's not in geographic coordinates, how does that all work? So in this example here, we might be displaying three different data layers on the map: data in geographic coordinate systems, data in UTM, and maybe data in state plane coordinate systems. And remember, for Oregon, there's a southern state plane coordinate system and a northern state plane coordinate system. But what we can do is we can just set the coordinate system for the entire map to the Oregon statewide Lambert coordinate system. And then basically what happens is, as these different data layers are displayed from the geodatabase onto the map, they're projected on the fly so that everything lines up. So the GIS software knows what projection they're in from metadata stored in the geodatabase for these three different data layers here, and it automatically draws everything correctly. So this all helps us to fix the map display kind of issue, and it's pretty much done automatically as long as we have the data in our metadata for these different data layers that we're asking. However, it does not help us with the analysis portion. For that, we would actually have to project this data from the geographic coordinate system into the Oregon statewide Lambert coordinate system, and then we could use that data for different sorts of analyses, such as buffering and anything else that we wanted to do with that data.